Polynomial functions of higher degrees. So we're going to talk about polynomial functions that are higher than squared. So things that are greater than quadratic functions. Okay, so polynomial function has a continuous graph, which means it's one fluid motion. If there are portions to the graph, it's not a polynomial function. Polynomial functions have graphs with smooth, rounded edges. So if it is like a V or if it takes a sharp turn, it's not a polynomial function. Those are pretty much the two things that classify polynomial functions. If I have the parent function f of x equals x cubed, the parent function for this would look something along these lines. So a function like that is the parent function for a cubic function. The domain of this function is negative infinity to positive infinity. It's going to continue forever this way and forever this way. The range of this function is also negative infinity to positive infinity. It's going to continue up forever. It's going to continue down forever. The intercept in this case is right here at its turning point 0, 0. And it's increasing on negative infinity to positive infinity. It's an odd function. Depending on what the function is, tells us what type of shape it's going to be or how many curves it's going to have. So with it being an odd function, we know it's going to be shaped more like an N. And that's what we're going to go off of. Now, tell me, let's talk about this in words first. Let's say I have a function g of x equals negative x cubed. How would this function compare to that function over there? What would be the difference, or what would stay the same? What's going on? How would those functions compare? Okay, so if it flips, what does that mean? My parent function looks like this. So flipping it would do what to this graph? Switch which one goes up, and, yeah, which one goes up and which one goes down. So it would look more like this. Okay, so it would flip it into that direction. What happens if I have the function h of x equals x cubed plus 1? H of x equals x cubed plus 1. What does that do to my function? Adding that 1 to the end. What does that do to this function compared to? It moves it moves up the intercept 1. Okay, so the y-intercept is going to move up to here, and then my function is going to continue the same like this. Okay. So you're going to have to be able to compare and contrast these. What happens if I have a function like this? And then I have x minus 1 cubed. What does that function change to? What does that function look like? The minus 1 tells me what? Not down. If it's not in parentheses, it tells me if it goes up or down. If it's in the parentheses, it tells me what? Left or right. And you always take opposite of what it is. So it's going to move to the right 1 unit. So it's going to start over here and come. Okay. So you're going to do lots of comparing and contrasting of polynomial functions in forms that are greater than squared than quadratic functions. On page 256, there is a chart that talks about end behaviors of functions. Okay, so when my function is odd, the first one is when it's odd. Okay, my function's going to look more like an n. Okay, when it is odd, and if the leading coefficient is positive. Okay, so when it's odd power and the leading coefficient is positive, it's going to look like that. When I have an odd power and the leading coefficient is negative, okay, it's going to face the opposite way. So instead of being like an N like this, it's going to come this way. When you have an even power, and the leading coefficient is positive. Okay. When you have an even power and the leading coefficient is positive, it's going to be shaped like a W. When you have an even and the leading coefficient is negative, you have a backwards W, basically. More like an M. Okay. So, depending on what the leading coefficient is and what the power is, depends on what type of graph I'm going to end up having. When it's odd, it's more like an N. When it's even, it's more like a W. The power also tells me how many possible turns I have. If I have a power, something like x to the fifth, how many possible turns could I have? Subtract 1. 4. So it's always minus 1. So if my highest power is a cubic function, I can have up to 2 turns. I don't have to have 2, but I can have up to 2 turns. If my power is a sixth, I can have up to 5 turns in my graph. You're going to work on applying the leading coefficient test, okay, which is this right here, and telling off of an equation what type of shape it's going to be, what's going to happen to it, is it positive, is it negative, and what's going on. Then you're going to use your graphing calculator to graph those and make rough sketches of them. Yes. From there, we then have to talk about relative extrema, and then we'll be done for today. Okay. The function, any function f, has at most n real zeros. So if I have a cubic function, I have 3 real zeros. Or I have some type of real zeros in that function. 1, 2, but up to 3 real zeros. Okay? And so when I'm trying to find those real zeros, that's also how many turns I have. So if I end up getting solutions when I factor something out and I get x equals 2, x equals 4, x equals 0, that means I have 3 turns going on in my function. So when you're trying to find the real zeros of a polynomial function, you have to decide x equals a is a 0 of the function. You have to decide if you have to factor it, or you have to decide if it's in intercept form and solve from there. So if I have the function, let's say I have f of x equals x cubed, and then minus x squared minus 2x. How would you go about solving this for the real zeros? What would you do first? You have to factor, so what do I have to do? Take an x out, because these all have x's. So then you have x squared minus x minus 2. Now, how do I factor that? What multiplies to give me negative 2 but adds to give me negative 1? This should be easy because 2 has two things that go into it. It is a 2 and a 1. Which one needs to be positive? Which one needs to be negative? This is positive. This is negative. So I set all these equal to 0. X equals 0. X minus 2 equals 0. And x plus 1 equals 0. So my zeros are x equals 0, x equals 2, and x equals negative 1. You're going to have to algebraically solve for zeros. Okay, I need you to do that for me algebraically. What happens if I have this? One last one. Let's say it says 0 equals negative 2, and then it says x to the 4th plus 2x squared. Okay, negative 2x to the 4th plus 2x squared. How do I factor this? What do you want to take out first? X squared and what else?
2.
Okay, I'm going to take out negative 2x squared so that my leading coefficient can just be x squared. And then I have minus 1. What do I have here when I have x squared minus 1? What, Dakota? Yep. What do you have there when you have x squared minus 1? How does it factor? Yes, it's x minus, well, yes, it's x minus 1, it's x plus 1. It's called a difference of squares. Two different squares, they have minus sign. So, I set negative 2x squared equal to 0. I set x minus 1 equal to 0. I set x plus 1 equal to 0. This gives me x equals negative 1. This gives me x equals 1. This would give me x squared equals 0. Take the square root. So x equals 0. Here are my 3 solutions for that. Now, what power was this? It's the power. What power is it? It's a 4th, yes? Okay. It's a power to the 4th. Okay. But I only have 3 solutions, or 3 real zeros. Okay. So here's the deal. When you graph this in your graphing calculator, you're going to have to check. So I have 3 real zeros, but I should have 3 turning points as well. So 2 of my turning points are going to be on points that aren't real zeros. And you'll be able to see that when you graph it.